Hello, welcome to a video about the p5.sound library called Reintroducing p5.sound. And I'm calling it Reintroducing p5.sound because I've talked about p5.sound a little bit in the past to do simple playing of sound files. But what the theme is this time around is kind of going deeper into what that library is capable of and really digging into it significantly more. So, without further ado then, let's get into the p5.sound library. So let's jump across to Atom, where I have a little example project that I'll be doing my usual coding in. And let's begin at least by just talking about the very basic usage that we know of p5.sound. So we're starting from a place of knowledge. So the basic thing that we know how to do is we know how to create a variable that stores a sound file. We know that in the preload function, we can load a sound into that variable by passing a path, asset_sound/bark.wav in this instance, since that's my placeholder sound. And then I'll create a canvas just to be a good tidy Kiwi. And then we know that we can play a sound basically by triggering it with some kind of user interaction, such as a mouse pressed. So if I define a mouse pressed function, which is called when the mouse is pressed, that allows me to play my barking sound. Yep. And so if I run this lovely program, see, I will encounter an error, and that's fine. Failed to load. So it's a typo. You can. I'm looking here at this 404 error. It's saying it failed to load it, and it's because I did not include an S here. Assets/sound/bark.wav. I could start this whole video again and pretend I didn't make that mistake, but I did. Here we go. We can't see the canvas because I forgot to make it a color. Let's just set the background just so that we can actually see where the canvas is. Okay, so when I click, the dog barks, and that's the basic use of the sound library, right? That's the main thing that we know how to do. Trigger a sound at some point in our program by playing the sound file. And that's all good, and that's often all that we particularly need to do with the sound library. That's the most common usage. However, it's not the only thing that we can do with p5.sound. And indeed, we should be kind of clued into this perhaps by the fact that if we go and look at our libraries folder in our project over here, we can see that we've got p5.min.js. That's the p5 library that does all of the drawing stuff. It allows us to have set up and draw and mouse pressed and so on. It's like the main thing that we've been using throughout all of these videos. But there's an entirely separate file called p5.sound.min.js, and that's the p5.sound library. The fact that it's broken out into a completely separate file should tell you that it is something of significance. And indeed, it's something that can do more than only play back sound files. So p5.sound is a separate library from p5 whatever, regular p5, vanilla p5. It's a separate library that is there to deal with sound stuff. And so it can do more than just play sound files. So that being the case, if we want to know what p5.sound can do, the thing that you do is you go and read its documentation. And this is a practice that we absolutely have to get used to as programmers. This is a huge part of what it means to be a programmer. And I'm also going to use this sort of review of the p5.sound library as a chance to talk about documentation and just to spend a bit of time looking at documentation and responding to it. So our first task whenever we're going to use a library, like p5.sound in this instance, is I'm going to open a new tab over here and I'm going to go to p5js.org, which we know is the homepage of the p5 library, doing fancy stuff there in the background. And I'm going to go excuse me, over here to the libraries section. That's just one section that exists. Now, there are lots of libraries on here, as you can see, and you can investigate those at your own leisure. Right at the top, though, the first one that is there is a core library, and it's called p5.sound. So let's click through to there. And what we end up with here is a not super friendly web page telling us about the p5.sound library. In particular, it's telling us all of the stuff that p5sound can do, and you can see that there is a lot. This stuff down here at the bottom especially is kind of mirroring the various possibilities that we see in the regular p5 reference list, right? All of the methods effectively that we can call, or functions that we can call, associated with the different elements of p5sound specifically. And you can really see that the stuff that we've been doing up to now, which really corresponds here to p5sound file at the top, load and play sound files, that's really only the tip of the iceberg, right? You can see that there's a lot more that this library makes available that we have not been using. And that's exciting. That should be something to feel excited about. It can be something that feels overwhelming as well, right? Because you look at this and you think, oh my goodness, there's so much that I'm supposed to know apparently to use this library. But it doesn't work that way. The thing that you should do is you should be excited because there's a lot of possibilities here. It's not the case that you need to know and use every single thing that we see listed here. You know, oscillators, envelopes, delays, reverb filters, sound recorder, whatever that is, fast Fourier transforms, that's FFT there. There's a lot of stuff, but you only use things in a library to the extent that they're useful to you. So it's important not to feel totally overwhelmed when you see the documentation and the possibilities. You should see these as potential opportunities that you may or may not choose to use. But the important thing is we do need to be able to read what the possibilities are and be able to put them into practice in order to potentially take advantage of them. And so that's the kind of stuff that I want to be talking about for the next little while. As a quick little note on terminology here, what we're looking at here, we can see it's being called the reference here for the library at the top of this page. This is very often called the API documentation of a library like p5sound. So API stands for Application Programming Interface, not the world's most friendly terminology. But you will hear that idea. People will tell you to read the API or look at the API docs, or they'll say some cool thing like that. They're referring to these web pages of documentation that exist for any library that you ever use that is there to tell you what the possibilities are. And these forms of documentation of APIs or references or whatever you want to call it, they tend to have a very similar form. There's a kind of standard way that they get written. So as you get more and more used to reading them, things get easier and easier on that front. So we're going to do some practice of that today. Okay, so we're gonna, for now, we're just going to explore p5.sound file a little bit further than we have. Before we do that, though, I want to point to a function that is signaled by this documentation that's maybe a little bit easy to miss, which is this one down here, user start audio. And this is a function that p5sound provides that is just intended to kind of smooth out our use of sound in the context of a p5 program. It's in relation to this thing that we have of browser autoplay restrictions, where we're not allowed to play a sound until the user has interacted with our page. And it just attempts to make that a slightly smoother experience. The truth of the matter is that we still have to wait until they click or do something, like press a key, before we can play sounds. But the idea, at least in including it, is that you're giving the p5sound library a chance to do things behind the scenes that may help. At the very least, it does not hurt to include it. So we would put it here, for example, in setup. So because we're going to use audio in our program, I'm going to say user start audio in my setup to just kind of tell the library, like, do what you can to smooth this out. Despite that, I still, have to do something like this, right? I still have to wait for a mouse press or something similar before I activate sounds. So it's just it's sort of good practice. It's the couth thing to do, if I like. So with that in place, and I'll just use this from now on when I'm going to play sounds in a program. With that in mind, let's go and actually explore p5sound file, which is this first section. So all of these different ideas that exist in the p5sound library, audio and amplitude sound file, etc., each one has its own documentation page. So generally it makes sense to click through to that to learn more. So this one's about loading and playing sound files, as we know. And we're going to see a fairly common setup, and this is common to, again, most libraries. So the first thing we see here is an example. And it gives us all of the code, other than the specific sound file, obviously, that we would need to carry out a simple use of sound. So if I click here in this box, someone's at the door. And we know what that's doing, right? It's playing a sound when I click. That's all it's doing, and we already know how to do that. So there's no surprises here. The only thing I will say, there's a few things that we can notice here. So one of those things is right here. You can see that they're using a special function called sound formats to specify the different formats that the sound file is in. They've got MP3 and OGG listed here. This is a thing that helps with cross-browser compatibility because the different browsers support different file formats, which is stupid but true. This is why in their load sound function here, they don't specify an extension at the end of their file, right? Doorbell, there's no .mp3 or .ogg there. They just say that the general file name is doorbell, and because they used sound formats here, p5.sound is going to go away and work out what the best sound format is to load for the current browser, and it will choose the right one and load it. So it's just a nice little piece of housekeeping that you can use. If you're thinking big about cross-browser compatibility, then providing MP3 and OGG is often a good idea. They're both compressed file formats, which is a good thing, and they just allow you to avoid some browser errors. So that's a thing that we can notice just from this and explain. The other thing that you might notice, which is a little bit gross, is the way that they're doing their mouse pressed function is just weird. It's not what we do. It's not how we've been doing things, and that can be distracting and or worrying when you're kind of reading some documentation. Sometimes you'll see things being done in a way that you're not used to because different programmers simply have different ways of achieving the same thing. The key is to understand the principle that's going on here, right? And I think that we can look at this and understand that, when the mouse is pressed, that's why it says mouse pressed, it's going to call this canvas pressed function, which is down here, and that will just play the sound. So it is very much the same kind of thing that we're doing here, right? It's just that we're relying on the fact that the mouse pressed function is already defined by p5 and can therefore play our sound inside that function definition. But apart from that, this example is the thing that we already know how to do. So that's all good. It's a good example, gives us the basic idea of what this part of the library does. The next part here is a description. So often there'll be a description in language, like regular human language, after we've seen kind of a description, I suppose, in computer language or programming. A description that just sort of tells you the general idea of what the library can do. In particular, it points out that files get loaded asynchronously, so you have to be careful about when you load them. This is why we're generally loading everything in preload, as it guarantees they're ready when the program starts. That's why we're going to ignore this for now. Let's just not worry about it. We're just going to use regular old preload. Only one file path is required, and then so this is this point, right, that we were talking about here. This is another way that we could do that cross-browser compatibility thing, is we could send it an array of different files that we could use depending on which format the browser needs. So it's confusing because they don't use that in their example. They use sound formats, the function. Good grief. And then they're just pointing out that we do need to include p5.sound inside our index.html, right? And that's what we do in the template. Here we have it right here. We're including the script tag for the library to make sure that the code for that library is included. So that's already taken care of. Okay. Then we run into some syntax. Again, a moment of potential confusion. Because again, this is not how we have been dealing with loading sound files. We've been using the load sound function, right? And indeed, they use the load sound function up here. So it's sort of irritating that their documentation is not really mirroring what they actually do in their example. That's sort of, I don't want to, I'm not trying to criticize them too much, but I'm just saying that's not super helpful that they've done things that way. This syntax is explaining how you create the sound file object. You can tell that it's an object, right, because we say new and then p5.sound file. So p5.sound file is the name of the class in this case, okay? So we're creating a new object out of this class, which is going to represent a file. And that is what load sound is doing in the background. It's just that we don't normally do it explicitly, so it's confusing to see it here. And indeed, we're not going to worry about this syntax here. We're not going to worry about creating sound objects in this way. The load sound function is perfectly good for us. So we'll quietly skip over that, because what we really care about in this documentation, and this is often the case when we read documentation, we tend to care about what the methods are. What methods or functions are available for us to use in this context. So we're in the p5.sound file context. So what can we do with the p5.sound file object when we create one? And this is a big list, and the descriptions are fairly good, right, of the different things that we can do. So there's isLoaded, that will tell us whether or not our sound file has loaded yet. There's play, to play it. There's play mode. It turns out that there's 2 different ways to play a sound file. Restart, so every time you call play, it starts again from the beginning. Sustain, every time you call play, it keeps going if it's already going, and otherwise it starts. Oh, sorry, sustain it, yeah, that's what I meant. It starts simultaneously. But there's a lot, right? So even in this one little part, this one little bit of the library, there are a lot of functions or methods. And I'm not going to go through them all simply because that would be overwhelming. But at least the first sort of key first step is it's a very good idea to read through them all, because you might see something that catches your interest and that you want to play around with. So for instance, you might see this add queue method. Add queue allows you to schedule events to trigger when a sound file reaches a playback point. So you can basically trigger things to happen. If you, for example, you're playing some music and there's like a big swell in the music, and that's the moment you want to trigger something to happen in your simulation or your program, add queue seems like something that you would want to investigate. And note here that it works both ways, right? Like it might be something that you want to do already, and so you're searching for a thing that might let you achieve that. But on the other hand, it might be something where you see that adding queues is possible, and it gives you an idea for what you want to do. That's a really important part of reading documentation. You're not always reading it to figure out how to do the thing you already want to do. You're also reading documentation to find things that you might want to do. So with that in mind, let's go find something that I wanted to look at, which is, where is it? Rate. So I think I've already talked about rate before, but I think it's a good example. It's relatively simple. We can go and look at it and kind of get the sense of what's going on here with a specific method from this part of the p5.sound library, right? Because the overall library is p5.sound. That's the whole thing. Then there's p5.sound file, which is a specific part of the library dealing with audio files. And then there's rate, which is a specific method from the sound file part of the library. So it's getting pretty specific. So the description here, set the playback rate of the sound file, changes speed and pitch. Values less than 0 will reverse the audio buffer. So that's an interesting piece of information that immediately makes me want to play around because reversing audio is fun and hilarious. So again, we can keep going deeper and deeper. So rate, you can see is a link, and we can click through to get the documentation just for this one specific function or method, right? And it's got the same basic structure, right? It's got an example. This example, let's see what happens. If I click, okay, well, we can see what that was doing, right? I was controlling the rate of playback by clicking and pressing and hearing the sound rate change as I move this little bar up and down. We've got some little visual additions here, right, so that I can see what rate I'm setting it to. You can see it's between 1% and what? Well, technically, I suppose it's trying to go up to 200%. Okay, so that's what that example does. You can see again they've got that ever so slightly confusing thing of using this canvas.mousepressed way of triggering a mouse press. But really the key stuff and the thing that you really want to kind of look for when you're looking at an example of a specific method is where do they use the method that you're looking at, which is rate, right? So we look through and we find it's here. So you can see that you use rate by specifying the sound file in the variable that you've loaded it into, my sound, .rate, because rate is a method of that kind of object. We know about object-oriented programming, so we know that this is a method of the object. And we tell rate the playback rate, as we can see from this very nicely named variable that we want to set it to. And as we can kind of guess just from experiencing the example, we're working out the playback rate by mapping the Y position of the mouse, the up and down, which we're saying oddly is between 0.1 and the height. I'm not 100% sure why they said 0.1, but sure. and we're mapping it to a range between 2 and 0. And this comment is completely incorrect, which is weird, but okay. They're mapping it between 2 and 0. So there you go. And then they're also constraining it. I guess that's why they think they're setting it to that range. But they're actually doing something slightly weird there. That happens a lot when you're reading documentation. Nobody's perfect. The key thing that we can draw from this is mapping the Y position to a playback rate, and then setting the playback rate with this rate method. So that's how that works. Importantly, though, they didn't do the negative thing, which I think would be the most interesting component of playing around with this potentially, although the very slow and very fast sound did sound pretty cool. The description here is fairly simple. Set the playback rate of the sound file. This is what we just read before, right? Changes the speed and pitch, values less than 0, reverse the audio buffer. Good, that's what I'm interested in. Again, they remind you that you have to include the library. Okay, I get it. And the syntax in this case, pretty simple. Rate is the name of the method, and then you provide a playback rate. I assume if you don't provide a, so this I should say as well, this is an important thing when reading documentation. We've got square brackets here around that playback rate parameter. The square brackets mean that it's optional. So you can call the rate method without providing a playback rate. I don't know why on earth you would ever do that necessarily, but you could. And if you did that, then it would play at a default rate. I'm going to guess it's a rate of 1. So you could call rate doing absolutely nothing and get the result that you expected, I suppose. However, we're very much likely to actually provide an argument in here to set the rate. So let's do that. Let's create a backwards barking dog. So now that we've read the documentation and kind of internalized how it works, we're free to actually mess around. We've already got a thing here that plays a dog barking right here, right in mouse pressed. So if I wanted to set the rate of that dog barking before I play it, that would make sense. I know that I want to provide the name of the variable with the sound file in it, bark.sfx, bark.sfx in this case, that's where I loaded the sound. I know that I then say .rate because it's an object and rate is a method of the object. It's a p5 sound file object. And then I can set the rate to whatever I want. And for now, just because I know that I want it to bark backwards, I'll set it to -1 because I'm curious, what does a backwards barking dog sound like, right? Let's go and listen to it because that's all that I needed to do. I've learned about this rate method and now I'm using it. So let's go check out what my dog sounds like now. Ooh. Sounds weird. I like how weird it sounds. So backwards dog sounds great. I'm happy. And the important thing is, like, when you try stuff like this out, as I've been saying, try and let that kind of inspire ideas. Like, what does a backwards barking dog make you think of? Maybe it makes you think of time travel. Maybe it makes you think of things going wrong in some really specific way. Maybe it makes you think of visuals of a dog moving backwards as well as barking backwards. There's all kinds of things that you can use to kind of jump off from, just from this one line of code, right? Bark sfx.rate -1. That can make you think of a whole program based around this idea of backwardsness. So it's important to let yourself be inspired. However, this is only one value, right? And it would, generally speaking, it's interesting to explore the possibility space. And that's kind of what, that's kind of what they were doing in the example, but let's explore the negative possibility space as well. So if we want to explore what this rate can do sonically, it would be a good idea to also take this idea of mapping up again. So let's map the rate to the x position of the mouse. So let's say that if our mouse is all the way to the left, we'll go negative, maybe -3 rate, and if it's all the way to the right, we'll go +3 rate. So how do we do that? Well, we're going to need a variable to store our new rate in. So I'll call it new rate. It's a good thing to call it. And when we're mapping, we're wanting to convert from the mouse position to a playback rate. We know that we should use the map function. What am I going to map? It's the x position of the mouse, so that's mouse x. What range is that meant to be in? What range is it in when it comes in? It's between 0 and the width of the canvas, let's say. Technically, it can be between 0 and the width of the entire window, but I won't get into that right now. 0 and the width of the canvas is the sensible range. What do I want to map it to? If it's at 0, it's all the way to the left. I'll make it a rate of -3. And if it's at the width of the canvas, that's all the way to the right. I'll make it a rate of +3. Then it remains to set BarkSFX's rate to that variable. I didn't say it explicitly, but hopefully you were with me. I moved the rate stuff into draw because I want to be able to do this dynamically. So every frame in draw gets called. I'm going to calculate the rate based on the position of the mouse right now and set that to be the rate of the sound file. So it's dynamically going to happen every single frame. So let's go and have a listen to it now. And actually, you know what? Now that I'm thinking about it, let's loop the sound file so I don't need to keep clicking to trigger it off. So let's go. Okay, there it is. So there's about 1, right? That's about 1, I suppose. So my mouse is sort of in the position reflecting 1, 4/6 of the way across the screen. As I go across to the right, the dog gets pretty frantic, starts sounding like a squeaky toy. Halfway, sort of around halfway, it's getting very slow. It's starting to sound quite scary. Starting to sound like a dinosaur. Now it's backwards. That sounds quite frightening to me. Sorry, I'm just listening to it. I forgot I'm supposed to say something. That sounds like some kind of alien space marine begging for you to spare their life. Bit more urgency there again as we get fast. Sounds like the space marine's going to explode. That's another thing to think about, right? Is like animating that variable so it gets faster and faster and faster and faster and faster until something happens, like a giant explosion or something. Who knows what could happen? But you can tell just by exploring the possibility space there of that rate, just with your mouse. That becomes a kind of a tool for design. Like you can really think about what do these different qualities of sound mean? What does it mean as I move between different qualities of that? Because we know that we can change the value in a variable over time by adding to it or subtracting to it. All of that's very evocative, and thinking about what that evokes is powerful. And notice that we're having all of these ideas purely on the strength of reading the documentation, right? We read that there's the sound file documentation. In the sound file documentation, we find the rate documentation. And then in that documentation, we learn that there's this big range of values that have different effects, and so we try them out. And that leads to thinking about what we can do in a program, a much larger program, that's kind of implied by our ideas. So it's super exciting. Like, it's a great thing to start reading the documentation of libraries and thinking about what those possibilities are. So yes, it's possible to get overwhelmed. When you look at the p5.sound documentation and it looks like this, and you're like, oh God, like how am I ever going to come to terms with this? The key is to take it piece by piece, both to sort of review what's there because you don't want to miss out on something that might be super interesting, but to take it, slowly, a step at a time, and to try and experiment with the things that catch your interest. First of all, just by looking at the provided example and then maybe working something up yourself. And this is something clearly as well, I should say, we need to practice, right? We get more and more used to reading documentation from libraries. It's not something where they're so well written that anybody could read them. You're a well enough trained programmer now to be able to read these things, but go easy on yourself as you get used to reading documentation, because it's not trivially easy. Okay. Oh, look at me. So that's what I have to say about the basics of encountering one of these libraries kind of for the first time. Reading the documentation can be fun. Experimenting with the possibilities even more fun, and you should treat yourself to having that kind of fun as much as possible. So that's it for reintroducing p5.sound. Hopefully I've kind of expanded your understanding of what that library is and where the possibilities are and how you can begin to read the documentation. And we will proceed with more of that in the coming videos. So bye for now.